Hi everyone, how are you? Hi. No, we just have night tenant or kind of night tenant. Hi, Hong Linh Khan. How are you? Do you stay at home or you are at dormitory? Are you at home or at dormitory? Yeah, good. I forgot the name of the leader of our class. So, leader, could you please help me to count attendance?
Thành Tâm.
Minty, right?
No.
No.
Not me.
Not you. So who is the leader?
Đỗ Thành Tâm.
Okay, Đỗ Thành Tâm. Are you here, Đỗ Thành Tâm?
Nguyễn Thành Tâm mà.
Nguyễn Thành Tâm. Are you here? It's okay, no problem. So Nguyễn Thành Tâm, are you here? Because we are using the commercial version for this live class, so it's more flexible for us to interact each other. It means that I encourage you to contact me to use the microphone because this makes the class more live. It is okay if you have any idea. I prefer you tell me other than rather than you write it on the chat session. Is it okay? You need to talk okay, Hoàng Minh Khang, rather than type. Okay, thank you. Just kidding. And why is one participants already to go out? Right. Nguyễn Thành Tâm, are you here? Okay, Nguyễn Thành Tâm is not here. So Lemon G, could you please help me to count attendance? Lemon G.
Từ từ thầy ơi, có mấy bạn không vào được.
Có
nhập ID mà không vào được đó thầy, đang bị lỗi.
Oh, what happened? Okay, I will wait 5 minutes.
Ủa, đời không?
Can we begin? 5 minutes. Okay, let's start. Could you please let me know which problem just we stopped last week? Please. This problem. Please we stop at this problem.
Yes.
Yeah. Today we try to finish this chapter, and next week we will move to another chapter. Okay, So how about this one? This problem, they give us a uniformly charged insulating rod of plant. They give us the length of the rod is the 14. What's happened? What? Who have just rod? Okay, this rod is bent into the shaft of a semicircle, as from this figure. And the rod has a total charge. This is the negative charge, right? And they ask us find magnitude and the direction of electric field at all at this point. The center of semicircle. Actually, this one is same as other problem that we already solved, because this rod is a matter with a, a side with a large side. It have a length of 14 centimeter. So we cannot treat this rod as a point charge. We need to divide it into many point charge, right? Do you remember previously we already solved the problem for example, we already solved a problem for this kind of problem. For example, a disk here. For example, we already solved the problem for a rod with this problem with a rod. A rod it have a length. The different thing is, in this case, a rod is bent, so the shaft is changed. That is the difference in this problem. So how to solve it? First of all, wait, the rod. I like red. First of all, we need to divide this one is into many very small very small DL, and it will have a charge dq, right? Because the total charge of a rod is negative, so in this case dq is negative. Okay, let's look at here. Let's put an acid is the point here. I call it this one is Y, and this one is no. Let's call this one is S. S. Okay. This one is S. This one is Y, and it's perpendicular here. So because dq is negative, so how can we determine the directions of dE here? So we can determine dE have the direction go to dl, right? You can also determine we have the alpha here. Okay, and you can call in this case you have this angle alpha. This one is the alpha. Okay, that's for one DE. But after you divide this, you will have electric field equal integral of dE. And because when you change the position of dL, the direction of dE change, so you need to get the side down of the dE. In this case, I can get a side down here, dE y. and DEX. Please let me know which direction is a symmetry of this problem. This, which axis is the symmetry axis of this rod? Please let me know. In this case, could you please let me know?
DEY.
The S on the Y symmetry. So in case you have DL here, you can find DL here, right? It have the property same as DL here, but the direction is opposite for the Y. So in this case, you can correctly can divide the E to the S plus the EY, right? Because there is symmetry in x-axis, so the y must be zero, because we have dy here for this dl, and you can find dl here. That's called dy here, and totally is will be zero. So in this case, you have the integrals become just integrating as direction, ds, and ds, the direction of ds not change, des not change, So what it mean? It means that finally we should have E equal. No, we can omit the vector DEX. No vector. It's okay. No vector. So in this case, we just calculate the integrals of ds. And how to determine the as DE as equal DE multiply. If I call this alpha, so this one alpha, right? So DES is opposite edge of the alpha, so it should be called DE multiply sin alpha. And please remember that alpha may receive the value from 0 to pi. Why alpha can receive a value from 0 to pi? Because alpha calculate from here, from y direction. So when alpha run from 0 to pi, it will plot a rod. Okay, and how can we calculate the E? The E can calculate in this way, equal K KE dq divide the distance between okay, the distance between DL to O, I call it A. Is they give us A? They didn't give us A, but we can calculate A. We have, you can calculate it, right? Because we have 2 pi A, this is the length of a circle, right? 2 pi A divide 2, this is the half length of a circle. It means it's equal 14 centimeters. I call it L, right? So it means that A equal to of meter, so I equal L divided pi. The important thing is A is constant. When you calculate the integrate, the factor that is constant is very important because you don't need to count it into integrate, right? You can move it down the integrate. That's why we need to determine A. Okay, so how can we determine dq? Dq here we can determine dq equal dl multiply lambda, right? Lambda is, what is lambda? Lambda is charge density of a rod. So how can we calculate lambda? Lambda is equal q divided L. Okay, and how can we calculate the L here? The L, please look at this figure. I can plot it here. I can plot it again here. Here we have the alpha, right? So here, this one is dl, and this one is a, right? So in this case, dl is very small. dl here will be very small, so you can calculate dl based on the radius a multiply d alpha. This is the basic formula when you study about a circle at the high school. So it's basic, nothing to discuss about it. So now you already have DL, you already have everything you have. You can substitute to DES here, and you can get the integrate. And please remember, because we count alpha from the y-axis, so please remember the boundary condition is for alpha is that alpha is from 0 to pi. Let's look at the result. So that's all. That's the way you should use to solve this problem. It's same as previous problem. That's right. So any questions here? So you can see here. You can see here the results here. I can do erase all. How can erase on? Oh my God. Oh, how can erase on? Cannot do this way. Oh, clear. Okay. Okay, so in this problem, we call it symmetry. So they told us that they claim that the y equals 0, right? So it means you just need to solve the e from ES or the ES, and you can get integrate from here with this theta here. Some students assume that you have a ring, a half ring here, and he assumed that it's also the same, but he assumed that alpha here. So can we can you solve that problem with, if you assume alpha here? It's okay, right? In this case, if you assume alpha here, you need to remember that it will go from here to here, here to here. Here to here is mean it's minus pi square. This is plus pi square, and this is minus pi divide to half of pi is minus half of pi, and this is positive pi half of pi. So it's possible if you assume alpha or theta. If you assume theta here, if you call theta here, so in this case, you need to pay attention that the boundary conditions should be changed. Okay, that is just another solution. Any question? Let me know if you have any question. If not, I will move to another problem. Is it okay?
Yes.
Thank you. Okay, this is the values. The values. It's, in this case, it just try to substitute the values of the scalars of the constant to formula they find here, and then they have the final value. Okay, 49 problem. I think you can read it at home because there's no new with this problem. They ask us in this figure, they show the electric field light for two charged participants separated by a small distance. In this case, the problems will be solved based on the number of light that we count. Okay, so the question number 8 is that they asked us to determine the ratio Q1, Q2. Q1, Q2 need to be proportional to the number of the light between Q1 and Q2. Okay, the number of light. So in this case, they state that they claim that the number of field lights emerging from positive and entering negative charge. So it start from not S because we have many lights. It start from the positive charge. Start from the positive charge. Here we have, in this case, because the light start from Q2, so Q2 need to be positive, right? Because it start from positive charge and stop at negative charge. It will stop at negative charge, so Q1 should be negative. And the magnitude of the magnitude of charge needs to be proportional to the number of the light that we count in this case. So please, if you want to obtain the ratio between Q1 and Q2, you need to just need to count the number of light in here. Q1 divided Q2 equal this one negative, this one positive, so it need to have a minus here, a minus side here. And how many light and add a negative charge? 1, 2, 3, 4, 5, 6. So we have 6 here. How many lights start from Q2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, 18 here. So you will have the ratio. It's very simple. Any question? If not,
No.
yeah, thank you. So now we go to this problem. The question is really long, right? So what's the answer? A proton are projected with a neutral space. Is in this case we have Q is positive, right? We need to know Q is positive or negative when we determine when we try to read the question. So they are provided with uh, velocities vi equal this one from a field region rule plans. Now, okay, we can describe the experiments in via this figure and electric field here. Why they give us? Why do they give us the negative sides? Because they already assign it with the direction, and you remember. Please remember that in this case, they put the y direction. They already put the y direction here. This is y direction, so we have the unit vector is chi. We already have the direction chi here. So electric field is opposite with the y direction. And initial velocity vector of the proton match angle theta with the plane. The proton to hit targets that light at horizontal distance. So, okay. When we read this problem, do you remember? Do you remember that the problems in fundamental physics 1 that we wrote a matter in the gravity force in the gravity field, and after we wrote it with ankles theta with the plane. So after they apply for a while, they drop into the ground, and they have a distance L as compared to the original point. So it's very similar to that problem in fundamental physics 1. It's right. Do you remember that?
Yeah.
Yeah. So we wish to find the angle theta as with the proton must be passed through the plane and strike target. It means that we need to find the theta so that the proton can hit the target that have a distance r as compared to the original point here. It's compared to origin here. So the question 8 was analysis model describes the horizontal motion of proton about the plane. The question is very simple. Please remember, if this question is in your final examination, please answer the question step by step. The question is not, the question 8 doesn't ask you to calculate anything. They just want to know which module could we use to analyze the motion of proton. So if we want to know the module of motion, we need to know the force that's applied on the proton. How to find the force? Actually, when the proton have motion, how many force can apply on proton? The first force is the gravity force. But remember that the mass of protons is very small, right? The mass of proton is very small. Is I remember this. it's around 10 power 29, 29 or 31. It's minus kilogram. So it's very small. Please remember it's very small because the order is the order is less than minus 20. It's less than minus 20. This means that the gravity force can be omitted. We don't need to concern the gravity force. So we just need to concern all the force. The force we need to concern in this case is the electric force, right? Because we have an electric field and we have the proton have the positive charge. So it's easy for you to determine that the electric force in this direction, right? Because it's sorry, not in this direction. How to erase this here? Very easy to erase. So actually, we have the arrow here. So you can find electric force here in this guy. Why? Because the proton is positive charge. The direction need to be the same as the direction of the electric field. So we have the force Fe here. Oh, we have Fe here. We omitted the gravity force. We just have Fe. And remember, the direction of Fe is same as the direction of gravity force. And this problem same as the problem that we already solved in fundamental physics 1. Is right. And in x direction, along x direction, there is no force. Fe in x direction is equal to 0. Is right. This is x direction. And sigma y direction is equal Fe plus gravity force, but we already omit this one. Okay, so that's only we have. Along the x direction, there's no force, so there's no force, so the proton need to have motion of constant velocity motion. It's right. It will move with a constant velocity. It's easy for you to have the velocity of proton here. You have Vy here, right? Vy and Vx. Yeah, in acceleration, they move with the velocity with s is constant. So once analysis motion describe the horizontal motion, yeah, it's moved with the constant velocity, no force and constant velocity. Yeah, that's the solution of question A. And the question B was analysis module describe the vertical motion of proton about the plane. Remember, because electric field it have the value is constant, right? The constant, so electric field needs to be constant. And remember, when you find the relationship between the force and the acceleration, you have F equal A. A is the acceleration of proton, right? So when this one is constant, here, and the m must be constant, So it's means that the velocity is constant, the acceleration needs to be constant, right? It means that in y direction, proton move with the acceleration should be constant, right? That is the answer for the question. How about the question C? Acute that equation 4.13 would be applicable to the protons in this situation. What's in the equation 4.13? Please look at the next slide. Here, this equation is from the fundamental physics 1, because our book include the fundamental physics 1 and fundamental physics 2, so it's continuous. So they mention that equations in this in this lessons. We need to review the previous equation. I already have you to review this question here. Okay, let I erase. This is the question I obtained from fundamental physics 1. The question here, that's I remember this 4.13. So what they answered? They answered acute that equation 4.134 applicable to the proton in this situation. Okay, look at. You should solve the problem here. The question says, I show you the question C, the solution of question C here. So you drew a proton with this velocity, right? You have theta with angle theta here, right? So you can find R here. First of all, you need to write the motion equations of proton in y direction. You need to replace G by A, right? Previously we already know A. No, we actually we don't know A, but we assume that A is constant because electric field constant and electric force constant. So A needs to be constant. And with the equation motion in y direction, you will have you can find H is the height that proton can reach, but we don't need to obtain H. We need to obtain R. So we need to write the motion equation for H direction. In this case, you can find finally you can find R here. Okay, this is from fundamental physics 1. Please remember it. Okay, so it means that we already solved the problem, the question C already, right? And now the question D is that we use equation 4.13 to write an expression for A in terms of V, E, the charge and the mass of protons and the angle theta. So it means that they need to derive the formula of R. It means that we need to find R as a function of V, E, the mass, the angle. Very sorry. In this place, look at it. You have actually you can apply the equation 4.13 to here. The thing is that you already have VI right to theta E MP, and how yes. Okay, so how can we find EI? I already taught to you. We have FE equal MA. M is the MP, right? AY. They taught that. FE equal electric charge because this is proton, so it charge is plus E multiply electric force. So you have AY, and you can obtain the equation, the formula of R, the distance R here. Okay, move to the questions. How about the questions E? Find two positions, two possible values of the angle theta. Okay, if you want to find the value of theta, is very easy for you. You just try to substitute the value of R into equation 4.13, and you will have two values of theta. Look at the solution. Please look at the solution here. Okay. We just need to substitute the value of R. Okay, the value of R to the formula of R here, to this formula, and then you solve the problem. After you solve this last problem, you substitute on value that the problem provided us. You can obtain sin to theta, and you can obtain 2 theta. I call this is sin to, this is sin theta 0, theta 0. Okay, it's into theta 0. So you have two cases. You have two cases. The 2 theta equal theta 0 and 2 theta equal 2 pi, right? 2 theta equal 2 pi pi minus the theta 0, right? Is this right? So in this case, the first case you have this one, theta 0, and the second case, no, this is 2 theta 0. This one is already theta 0 divided 2, right? And this one you have. Okay. Question? Or it's more easy for you if you assume that it's 2 theta 0. 2 theta equal 2 theta 0, and okay, it's more easy, right? So this one is theta 0 equal 36.9. Okay, that's it. The solutions of the question E. And how about question F? Find the type interval range with the protons about the length in Figure 23.54 is a possible theta. Okay, after you have the value of theta, you just substitute it to the equation, the motion equation in x direction, and you will have a type. This is the problem in fundamental physics 1. Just how can you have this? Because please remember that you have y equal s equal si plus vsi multiply t. If you assume, if you put the origin here, so sy needs to be 0. So you have, in this case, you have s equal v t, and x equal vt, and remember that x is equal r, right? And r, it depends on sin theta, sin theta. But how can solve it? You can obtain, so you can have here, right? R equal vi delta t, and it depends on this one, depend on theta here. And you can substitute theta into this formula, and you obtain the type. You obtain the type. So, question? If not, I will move to next question, next problem. Okay, how to solve this problem? We have a small block of mass m, a charge q. We don't know the size of the charge, or they will give us. It's placed on insulated prison list. Prison list means the prison force. The prison force equals 0, right? Do you know the prison force? The prison force is the force occurs between two masses when you put one on the surface of other one, and if you rub it, it will occurs a force that the force occurs is the opposite with the direction of the motion, right? That's we call the prison force. But in this case, there is no prison force. Actually, when you study in fundamental physics 1, there's many kind of prison force. The motion prison force, the static prison force, right? In this case, the static prison force is equal to 0. Remember that. And we have the inclined planes have with angle theta here. And an electric field is applied parallel to inclined. It means that electric field have this direction. Actually, we don't know the direction of electric field, but we don't know exactly the direction. This go up or go down, but we know the schematics. That's the general schematics of the electric field. We just know the acid. We don't know the direction. We know the acid, right? It's parallel to the surface of the inclined plane. Okay, they ask us find an expression for a magnitude of electric field that enable the block to remain at rest. It means we need to find the expression, the formula for the magnitude of electric field. They ask us E. How can we find what is the formula of E to keep this mass E at rest, it means there's not motion, right? It's motion, it's stable, it's unstable. So let's analyze the force here. I have a mass here, right? Actually, it have a mass, so the first force we need to know is the gravity. Gravity force pi. How seconds force? And you remember that because this matter, this object is on the surface, so it's natural have all the force. I call it the repulsive force, and okay. So total British force needs to be here. Okay. So we will have the direction of sorry. The direction of n and pi. So we have pi plus n equal this one, right? Equal this one, this force. In this case, if we don't have all the force, the small block will move down. So to keep it at rest, we need to have another force that opposes with the total force of the repulsive and the gravity force. So in that case, we call that force is the electric force, right? This means we have electric force in this direction. Yeah. Okay. We call it FE. Got it. The problem right now is that P plus N plus FE need to be how much? Zero. Yeah, very good. Okay. Try to solve that problem. It's easy for you to solve that, right? Because you are familiar with this kind of problem when you study fundamental physics 1. Okay. So could you solve it at home? Student, this alpha, you can apply y and x acid here. Let us yeah. This is y axis, this is x axis, this is y, this is x, right? And you can solve it. You can find out in, it means that total F in y direction, it should be 0, 0, and total F in x direction, it should be 0. This y direction you have n and pi. You have his pi y, right? So n and pi y need to be equal. In x direction, you have p pi p s need to equal fe. Yeah, that's all. So this means you have in acceleration is we have pi y equal n. You don't know n, but you know pi y, py, right? And y direction you have p x equal fe is mean e. Sorry, which means q ke q. Please no QE. Okay, so if you have PS, you will have E. How to calculate PS? PS is the opposite S of alpha. It means PS equal P multiply sin theta, right? Okay, so please solve it at home. Question? Question? Do you have any question? Okay, if not, please move next. Here again, plus right, super f is fy equal to 0. Yeah. Is the letter of the class here? Please help me to count as standard. Please. Can someone tell something to me? Can someone tell something to me, please? Student. Yes, one student tell me that. Lemon G, are you here? Lemon G, please answer me.
I'm here.
Okay, please help me to count as standard. And Lemon G, Vũ Đức Khải already told me that his electricity, the electricity at his home already cut off, so he cannot attend. He cannot continue attend our class. So please count his name in your list.
Yeah.
It's okay.
Yeah.
Vũ Đức
Yeah, I
Khải.
see.
Okay, thank you. And you can upload it into our system, or you can send me to an email. Thank you so much. And actually, I already recorded our video. So if there's some point that's not clear, you can review the video. I think that's best for you. How should we do that? Okay. Okay. How about this problem? No question, right? Actually, we need to stop at night because there's some teacher that's already registered that time slot. Actually, because I use the commercial version of Zoom, so we need to register the period, and our period is almost past, so we need to go quickly. How about this one? Student, it's the same as previous question, right?
Yes.
But no, there is a problem here that lambda is not constant. It's not constant. So you cannot assume that theta in this way from h to r. You cannot. You need to follow you need to follow everything that the question provided. It means that they call the theta and you need to solve this problem is that the theta. That's just one, the different one. And everything needs to be the same. Actually, you need to solve this. You need to solve this at home. You need to solve this at home. And if you have any question, please ask me. And we move quick. This is the solution. So remember that lambda depend on theta. Okay, it's not constant. That's just the only difference is just the theta is not constant. Okay. And how about order? It's just get integrated. Okay, how about this problem? This problem is you need to remember the hook law. Hook law. What's a hook law tell? Remember, F equal minus K S. Remember hook law in the fundamental physics 1. Remember that? Okay. The key point in this problem is you need to remember hook law. Okay, you can review in fundamental physics 1, or you can go out from the book and look at it again. But if you don't look at this, I think you remember this because we studied this law many times. In the fundamental physics 1, or when you study at high school, I remember that's the class 10, right? So the key point here is just that's very simple. How about this one? A ring, and actually they ask us to find what? To find they have a negative charge particle minus Q is placed at the center of a uniformly charged ring here, right? When a ring has a total positive charge Q, as shown with the speaker, the particle confined to move along as it moves more distant along as it and release. So that the particles oscillated in simple harmless motion with a frequency. Oh, it's symmetric question. When you study at high school, in the class 12, right? In the class 12, you usually face this kind of problem. The important thing is when the charge stay here, the total force is equal to 0. But when you pull this here, the total force different 0. And actually, when you put it here in here, the force will have the resonance to the origin, right? The force need to have a resonance to the origin. And if it's here, if it moves to here, the direction, the force direction needs to move to origin. It means that if the charge is moved out a stable position, the force will occur and pull is into origin. The key point of this problem is that. And you just need to find the force. How you find the force? Is you already know, electric field is one point, it's far away from origin, right? You already have electric force. In this case, if Q is Q of the ring, Q positive, So you have electric force here. And we already find the value of E. So it's very easy for you to find E, Fe. Fe equal minus, this is the value of the particle charge, right? E. Okay. You already have key E, you have Fe, and please substitute the value of E into this formula, and you will have the equation to be solved. For example, here you already find this one in previous problem. Okay, yeah. So you can find F by multiplied Q minus Q with E, right? And you also have you, if you assume that in this kind of question, if you move the the point charge far away from the center of the circle, you will move it away the circle. You will move it far away from the circle. It cannot vibrate. The condition of this problem is that S is really small, as compared to the radius of the circle. So when S is really small, so we can omit S. So that's why you have this formula. And remember, you have F equal MA is equal M actual point. Do you know to actual point? Actual point is, it means the square S per dt square. Do you remember this one? And actually, it's also equal to this one. So it's same as harmonic motion equation, right? The equation of force of harmonic motion is here, So just try to solve it, and you will have the solution is S equal A since omega t plus P0, right? This is from high school. Please review it. And you can have omega or you can have F. In this case, they call F here, right? K. They just try to assign the Hooke law here. How can we find the K? K is here because they assign that F also equal minus Ks, and actually K is for this one, right? Okay, that's all for this kind of problem. Question? Oh, luckily we go through the end. Any questions, please? If not, we can stop here. You can review this video later. I will upload it into the YouTube, and I will provide you the link on the system. So don't worry about that. Don't worry that you miss some points in my lesson. Question, students, please. Thank you. Okay, Minji, please help me to count as attendance and send it into my email. Thank you so much. It's very nice to meet you today to study with you, student. Thank you so much, and see you next week. Next week, from now, we will study every week. We will have live class every week. Remember that. At the same time as today. So if I don't inform you any information, you need to understand automatically that we have class every Friday morning at 8 a.m. And because we have a limit time slot, so please attend on time. Because after 5 o'clock, someone maybe use our account, and maybe I will be locked out. I cannot use this account after night. Luckily today, why 9:20, but no one used. But remember, someone maybe use after night because I only register 1 hour from 8 to 9. Remember? Thank you. Bye.